What a Wednesday it's been. How's everybody doing tonight? Welcome to Facebook Live After Dark. My goodness, this weather pattern is so active. I'm exhausted, so I probably won't last long on this Facebook Live, but just want to give you a heads up that we've got a system coming in Friday. I think surprises are going to be in the making. They already had surprises in Oklahoma today with a wintry mix and snow, and the snow was heavy enough where it accumulated, and it did accumulate on roads. Now, granted, most of the roads were wet, and it wasn't a super big deal, but they did issue a winter weather advisory, kind of a short fuse winter weather advisory. So, hello to Alicia. Hello, hello. Hope you're doing well. Hi, Angie. Welcome. And Pamela. Well, Glenda's saying Pamela Woodall. That's not it's not Pamela saying hello, but she's probably saying, hey, check this Facebook Live out. All right, here we go. So first of all, it's real breezy now. The winds are whipping up. This has been quite the system today. Severe weather in the southeast, in Mississippi and Louisiana, all sorts of stuff. Then we had some incredible rainfall totals, especially in the River Valley and south. Russellville got nearly 4 inches. And then you can see the high resolution rapid refresh showing that the snow is, or the precipitation is coming to an end. So here's the backside of the system. This is the wraparound. There might be a few snowflakes that get squeezed out on Thursday morning, but I think for the most part, this isn't going to be a big deal. But I do have a little 30% mix just because of the wraparound. You can see that mix mixing in with some rain and snow. So then the system lifts out. The weather's going to be beautiful on Thursday. I mean, we're looking at 50s. I think the model is underdone here at 130. I think it's going to be in the mid 50s. I think River Valley might even be in the low 60s. So models don't handle temperatures and warm ups very well. So what are we talking about with this winter weather potential? Well, you saw right before we launched the stream, the vorticity that's developing. And I hear you, Misty, no more. I don't want it either. I'm tired of the winter weather. I'm tired of these active weather patterns and how crazy it is. It doesn't make my job any easier trying to forecast this garbage. But you're going to see here for Thursday night and into Friday morning, precipitation starts to develop. Now, what's interesting about this is that there's going to be all these little mesoscale features of this system, creating and enhancing precipitation. Not only that, but increasing the precipitation rates, and finally, possibly snowfall accumulation. Now, the models are coming in colder, and you saw how quickly that changed over. So, first of all, let me preface this. This is not going to be ice. You don't have to worry about freezing rain. That's not this type of weather pattern. We don't have that warm layer of air in the mid levels where it takes those snowflakes, it melts them, and then refreezes them on contact. We don't have that. But we do have some slightly warm air at the surface, and temperatures aloft are a lot colder as this system dives in. And I think this system is a little underrated, in my opinion. I think it's going to be stronger than expected. Some of the high resolution models are showing that. The GFS is garbage. The new GFS is crap. I'm using that word because it's frustrating and it's annoying, and it doesn't even barely show any precipitation. I'm like, go home, you're drunk. But here's what I wanted to show you, and I can't remember what I was going to do. And I will be looking at accumulation and stuff like that, but now I can't remember. All right, let's go back to this HRRR, and we're going to show you here over time oh, that's right. I remember. Let's see here. So it's going to be an explanation graphic, and you're probably wondering, well, how can it snow if it's above freezing? And it's because the air aloft or the air above our heads is colder. And I don't see the graphic, so I'll skip it. I was going to try to find it for you. Snow melting, snow. I'm tired of the snow. I don't really want it either. But anyways, yeah, we'll figure that out. All right, let's go back to the HRRR. and we'll look at some of the models, and then I'll kind of give you my 2 cents. And I got an accumulation map that I made. So here's Thursday afternoon, evening. This is the latest long range HRRR. And we're going to kind of step through this slowly. See how those temperatures are already in the mid 30s? We'll probably get a little sleet on the leading edge, on the initial leading edge. Then you see at 3 a.m., this starts pouring in. So if you're watching this, yes, Lisa, you will be getting snow in Bentonville. In fact, a lot of places are going to see snow, although you wouldn't know it looking at the forecast tonight from other sources. And there you go on Friday morning, this wraparound starts to take place. Now, temperatures could drop down to freezing. And if you're like, well, it's above freezing, it's not going to be a big deal. Oh, yeah? Well, this is not the same as January 24th, 25th, but remember, that was above freezing most of the time. And did that cause issues? You better believe it. Probably caused more issues power-wise and power grid-wise because the snow was so heavy. Now, we're not expecting those snow amounts because the moisture is just, the system isn't quite the same. But you're going to see precipitation that will change from rain to snow. And then you'll see by Friday, late morning into the afternoon, that system starts to move out. Or does it? Well, that remains to be seen. So here's the different models. I think this is kind of funny that the NAM is just going absolutely nuts. Here's a look at the snow accumulation for the graph. Notice that it's picking up on those higher elevations. I 100% believe this. The European, tenth of an inch. But again, there's all these small scale features that I don't think the models are picking up on. The GFS, this is not the 0Z GFS. This is the 18Z. It still barely shows anything. And then the NAM is like, bring on the snow. That's crazy, isn't it? And while I don't think this is going to happen, it gives you an idea that there's going to be some small scale features that the long range global models cannot pick up on. So what am I going for my accumulation map? Well, this is very, very, very preliminary, but I do believe that there's going to be a little localized area of snowfall, and I'll show you the reason why. And if we zoom in here, a dusting possibly as far south as the River Valley, a dusting for areas in Bella Vista. And I keep in mind, this is hard to explain exactly where this is going to take place, but up to an inch, and we got 1 to 2 inches, and higher elevations possibly way over what we're expecting. Well, why is that? Because there's going to be potential convective elements to this snow. the NAM is wiling out. Yeah, it sure is wiling. So here's the thing, Doris, probably won't be closed. And they'll be fine. And then all of a sudden, they're going to have to scramble and do an AMI day or do an early release, which is worse with people getting out. Now, there's always uncertainty how the roads are going to behave, and it all depends on the snowfall rates. If we get like really heavy snow, which is possible with this type of system, then we'll get accumulation, and it'll even accumulate on the roads, and it'll cause issues. It'll come slushy and slick and stuff like that. Now, check this out. This is the vorticity of this system. First of all, I'm going to go back to the water vapor because you can already see it starting to develop and tightening up a lot more than what some of the global models show. First of all, there's a lot of rising motion. There's already snow developing, and you're going to see this system really cranking up. This is the beginning stages. One of the things that kind of is a little bit nerve-wracking is that this system will be intensifying as it dives in. Yes, I know it's positive tilt, but still, regardless, this is a very big vorticity lobe, as you can see, is intensifying. I don't think the models have all the precipitation trends correct, because look at all these little pieces of energy that can really spark off some snow. Let's go back to what happened tonight. So let's look at this. This is the system that brought surprise snow. Well, guess what? They weren't expecting it. Models didn't have that on the wraparound. Look at all that vorticity. All these little pieces of energy are out ahead of it, providing lift that the models didn't have a clue about. And so now you can see that system lifting out, moving away. And look at all that snow on the backside of that system. A surprise snow. Yeah, the wind is really cranking right now because of this system moving through. Well, here's a system that comes in on Friday, and it's intense. It's going to have a lot of lift, and it sticks around. Now, there's additional pieces of energy moving in. Now, there is a little uncertainty as to the amount of moisture, but I think it's starting to become a little more clear that we are going to get um, accumulating snow in spots. So we'll see. We'll see if there's a tune change in the forecast because I went 70% as of now. The wind is blowing really hard. Absolutely is. Talked about that on the weather tonight. And look at these gusts, nearly 40 miles an hour at Drake Field, nearly 40 in Bentonville, and nearly a 40-mile-an-hour gust at XNA. So some really some rough winds. You can see it on our WeatherBug cameras. Look at the flags waving in the wind. And so you might be wondering why that's occurring. Here's the reason we're seeing that. It's all because of this low pressure system. So pretty tightly wound, compact low. Now you can clearly see that wraparound probably going to miss us. Number one, there's a dry punch coming through, and you can see that lifting off to the northeast. But there is a look at that snowfall accumulation that's moving northeast. I mean, that's pretty much understandable because you look at the track of the low and it's missing us. But Alex, I'm going to show that here in just a second. So there's system number, what, 4, 5, 6 this year? No, I mean, for this week, it's system number 2. That's moving out. Here's the next one, diving in from the northwest. And so look at this. First of all, this is not being scoured out at all. Models are underdone. There's a lot of moisture there. Yes, the dry punch pushes east, but that's about it. And then it's gone. Then we got more moisture that's going to be going to be moving in. So there you go. The roads will be good initially, but I think some higher elevations will definitely get covered, and there's going to be some issues. Snow brings spring storms. You got it. Oh man, we've got several waves of precipitation coming in. So all right, let me show you real quick the computer models because someone asked about the instability aloft, and there is some. And in fact, you can start to see a little bit of that. Let's go to here. Let's bring this up. Okay, so first of all, we're going to bring up the wrap, and this is the long range wrap. So here's the system diving in, definitely showing precipitation. A very localized mesoscale feature and banding that could really lead to some heavy precipitation. If you look at the P-type, it's pretty much all snow and heavy snow at that. Now, this is no slouch, folks. You look at the DBZs on this, and we're talking about 35, 40. That's pretty darn heavy snow for this area, for something to watch. So you're looking at the potential for some heavy snow initially and briefly. Now, this all happens Friday morning. We'll get back to the timing on this, but there's a look at the system. And, you know, that doesn't just move out really quick. It's several hours of precipitation. Sure, it's not a super big system, but this thing wraps up right on top of us. Now, when we look at the, you know, what everybody likes to look at, snowfall accumulation maps, it's like, whoa, look at that. That's like, you know, nearly 4 inches in southern Washington County. Not so fast, because remember, the temperature isn't cold initially, and we have temperatures above freezing. So a lot of this is going to melt as it comes down. So the best thing to do is look at snow depth. And I think this is a little underdone, but you can see that it does show a little bullseye of some snowfall. This is the snow depth on Friday. Now, the roads will be initially okay, but I think that there could be some issues with some slush spots, and that could make it a little slick. So I wouldn't doubt if a winter weather advisory gets issued, not tomorrow, but Friday morning when you wake up and it's snowing. Now, this is what I wanted to show you. When we look at convective and you look at the mostly unstable Cape, you're going to see just a little bit showing up to our south. Now, here's the interesting thing. We're going to look at the HRRR, and we're going to look at something called lightning density. Now, this is the potential for lightning which, by the way, this type of system can do. And look at that. We have a little bit showing up over northwest Arkansas. So the chance of thunder snow is not out of the question with this type of system. Now, if you get that, you throw off your totals and you get a lot more precipitation than you're expecting, and all bets are off. So that is a few hours of some lightning potential. This system could very easily overperform, folks. There is no doubt in my mind about that. That doesn't show any. Well, that's surface-based CAPE. You're not going to get surface-based CAPE. Look at all this instability, though. It's not a lot, but for this type of environment, over 100 joules per kilogram of mostly unstable CAPE is up there. That's not bad. I always love these little systems because here's what I say. This is my little saying. It's the small stuff that makes the big stuff happen. That's what it is. It's the small stuff that makes the big stuff happen. And this initially is the small stuff because it's a little short wave that the models aren't really picking up on with the global models. And yeah, it's going to be initially some cold rain, possibly some sleet, and then it turns to snow. No, the roads weren't okay at all. Now, I will say this, that we're not going to get as cold as we did. And let's see here. They're coming home Friday. What time should they head home, do you think? Thanks, bud. So if they're up in Big Cedar, well, I mean, they'd hate to come home Friday, but the earlier the better, Nicole. If they can come home earlier, that's good. The ground is already soaked. Absolutely. The ground is completely soaked. And we've got more rain coming in next week, and next week is going to be trouble. Is this a northwest flow storm? That's a good question. And the answer is no, it's not really a northwest flow storm, but it is diving in from the northwest, David. And, you know, if they dive in from the northwest and they're tightly compact, you got to know it's northwest flow. So here's a look at that system diving in. But you can see that. Let me bring this up here for you. You can't see anything if I don't bring it up. There's a look at the system diving in. Just a little short wave. And then look, we have tremendous amount of lift in what's called the left exit region of this jet. So what you do with the jet stream, and when they talk about jet quadrant theory, for those that don't know, I'm going to pause it right here. And so what you do is you take this jet and you divide it up into 4 quadrants. So let me go ahead and do this real fast and get rid of the arrow so it makes more sense. So we're going to take this, we're going to divide this jet up into 4 quadrants, just like that. So you have 4 quadrants, and 2 of those quadrants will bring tremendous amounts of lift. And that would be this one here. So you have the left exit region. Oops, hold on. Left exit and right entrance. It's really hard to type when the keyboard's off to your side. So the left exit, right entrance region. Here's where your ageostrophic component leads to rising motion. And look at where we're at. We are in the left exit region, and we're also, the right entrance is to our south. So that's not northwest flow, although the system is diving in from the northwest. So it's a little bit confusing, but there you see that with that left exit region, we're going to get precipitation, and then that little wave comes through, and then some additional wraparound takes place. So it kind of gives you an idea with the way the left exit and right entrance region works. And again, the models are kind of just all over the place. So let's show you what the latest graph is showing. Here is that little wraparound for tonight into tomorrow. Beautiful weather for Thursday. Here's the snow. It still doesn't have a good handle on it. It did, and now it doesn't, and then it did, and it's starting to increase its precipitation, but in my opinion, not enough. There's no reason why this shouldn't be showing precipitation at about 6, 7 o'clock in the morning. It shows it being too dry, but I've looked at the soundings and it's precipitating, so it shouldn't be doing that. So that's actually something wrong with the model. I appreciate it, Brandon. Yeah, we've got the potential for thunder snow. We got the potential for snowfall accumulation. One more thing I want to do. Come with me over here to our. It says it logged and registered. I love this camera, by the way, because it can follow you whenever it works. So what we're going to do is we're going to load up these SKUTs. I'm going to get the very latest ones. Load the profile, get the profile. This will take a little bit of time, but we're just going to geek out a little bit. Wind is definitely cranking up, and that's because this low is coming right over our heads right now. Let's see if this is any type of winter weather on the backside. Probably not. Not cold enough yet, but it's really close. Yeah, no. Not cold enough yet. There might be some snowflakes mixing in if you're up and at them early in southwest Missouri. So the reason that it's not going to start off as snow initially, and that's why when you look at snowfall accumulation maps, you're not seeing a good representation of what's actually going to happen because it's taking every single liquid equivalent of that precipitation and converting it to snow. On top of that, it's also a different ratio. It's like a 10-to-1. We went through this last time in late January, where this is a wet snow. It'll be a great packing snow again, and it'll be like raining, basically snowing slush balls, if you will. All right, profiles are complete. I'm going to bring this up. We're going to dive into SKUT soundings using something called BuffKit. And BuffKit's a great program that is free. It's a little difficult, a little clumsy to use if you don't know what you're doing. But here's what we've got. I'll bring this up. So this is our SKUT. We're going to load up the latest model for, and this, by the way, is what's happening for right now. And there it shows a little bit of precipitation happening. So about midnight, we get a little burst of precipitation. It's not quite cold enough for snow, but very close. And then it's gone. And then the sunshine breaks out and it turns out to be beautiful. So why doesn't it start off as snow? Well, it's all because of the surface temperatures, and the low-level temperatures are too warm. So if you missed this earlier, this is a SKUT. SKUT is where the temperature lines are skewed. This 0 degree right here is a 0 degree Celsius line. If we go forward in time, you're going to see that that is above freezing. So there is a large area above freezing, but not only that, there's not a whole lot of dendrites growing in this dendritic growth zone. That's this line right here and this line right here. That's the -12 to -17 degrees Celsius dendritic growth zone. When the temperature and the dew point are very close together like this, which it's starting to be, that's called saturation. Now watch what happens. Those red and green lines get closer, meaning 100% relative humidity. We can start to see now a dendritic growth zone. But notice the temperatures are still borderline freezing. It always has to stinking follow the 0 degrees Celsius isotherm. Every time. I mean, it never fails. I name every single system. It always does this. It's so freaking annoying. But there's a look at that. And then watch what happens. This goes from a rain to very, very quickly a heavy wet snow. And we're talking about some heavy snowfall. I mean, 3 dots right there. You get an hour, hour and a half of that. And then look at how quick it dries out. But it dries out just briefly. That doesn't make sense to me. Why would you dry out unless you had a little bit of a dry punch? But this is some things that the models do that don't make sense. So there's the dendritic growth zone for 1 hour. It takes it, it clears it out. Then it brings it back with a passion. And then you can see it's still snowing all the way through about 2, 3 o'clock. This needs to be talked about. And that's why I'm doing this Facebook Live. And then it's out of here. Then it dries out. Then we get the dry punch, and then the system's gone. Now, notice the temperatures Friday night are going to be dropping below freezing. So Saturday morning, any wet roads will freeze and will become a little bit slick. So it has been the winter of slick roads. So now let's look at the GFS. Here's the GFS, and it starts off right away as snow, but yet it doesn't accumulate. What? What are you doing? And then it has this thing right here where it has this really dry air in the low levels of the atmosphere that doesn't really kind of make sense to me, considering we're so saturated right now. Then it dries it out. So that's why the precipitation isn't very heavy with the GFS. Let's look at the RAP and see what the RAP has. So the RAP has rain. That makes sense. I agree with that. Rain Friday early morning, shortly after midnight. Then it turns to snow by about 5, 6 o'clock in the morning. And at this time, the roads will probably be fine. But then all of a sudden, the snow starts coming down heavier, and then it's gone. So this is a quick burst system that's moving in. There won't be any lower ratios. There's just no way, David. That's not going to happen. Well, yeah, I thought you're saying with lower ratios. No, that's not. Winds were cranking in Rogers. I know. We talked about that. That shows you the intensity of this system. So that's what we look at. And the reason I like BuffKit is because I can use this slider and I can see the trends. Whereas with models online, you got to click and then it refreshes the page and it loads each individual one. And it's just kind of a little bit of a hassle. So let's go down to Fort Smith. Let's see what Fort Smith does. Fort Smith does see a little bit of snow, as you can see, but it's also mostly rain. But it's close. Model all it has to be off is a couple of degrees, and bam, you get some snowfall there. Let's look at Harrison. Harrison probably is a little bit more, and there you can see this is going to snow. I mean, for someone that doesn't have precipitation chances very high on Friday is crazy. And I'm talking about apps, not talking about people, individual people. I'm talking about apps. They should be up there. Bet you Josh bumps this up to maybe 80%. I was contemplating 80%, but again, there was just a little bit of that uncertainty. So you notice the winds, 5 to 25. The reason it's 5 to 25 is the winds are going to be weakening tomorrow afternoon. Yeah, Mountain Home, Melissa, it's a little bit out of my area, but I know you watch from there. I wouldn't expect a whole lot of Mountain Home. I think this system is going to be very localized, very, very localized, and terrain induced in terms of the heavier accumulation. Also precipitation rates as well. So here's a look at that timing, which is exactly what you showed you. And we just accounted for it coming in a little sooner Thursday night. But there you see it popping up. So yeah, if we go to an accumulation map real quick, we'll show you that this is extremely, even with the HRRR, this is extremely localized. So let's look at this here. Here's the HRRR, and look at that. That's going crazy. Now remember, this is not snow depth. This is snow accumulation, and it's using a 10-to-1 ratio, and it's not good. I don't think she can pick us up. But if we kind of zip around and we look, you'll be on the cusp. But this is going to be very localized, and then this system lifts to the northeast. It's a real unusual, weird system, the way that it's so localized. But it's the small stuff that makes the big stuff happen. So here is the HRRR for local, and again, this is just showing all liquid equivalent, turning it to precipitation. I don't think that necessarily happens. So, all right, guys. Well, I think that about does it. I've got to enter in some forecast numbers. We're keeping track of that forecast more than you know, by the way. If you think meteorologists are always wrong and, we don't really care about if we forecast correct or not, we do. There's no doubt about that. And we take a lot of pride and a lot of effort into trying to get the most accurate forecast. And I think you're going to be seeing some big time changes in the wording and the verbiage on this system tomorrow. So it's not the system tomorrow, it's a system Friday, but tomorrow you're going to see a lot of different changes. People are going to be talking about it a lot more because the shorter range models will pick up on it. The smaller scale details will pick up on it. Here's this accumulation. Oh, Larry, next week. Always looking to the next thing. I will show you that here briefly. But there's my accumulation map. I really think that there's going to be a localized heavy snowfall for areas in those higher elevations, and it's going to be very small scale. But I think this could be an interesting system. Who knows? It could end up being bigger. We'll see. So what about next week? Next week, my goodness, we've got all this jet stream energy. It's southwesterly flow, so it's extremely active. Another wave train of systems comes in. We could see severe weather on Thursday. After that, here comes the next system that's diving in for the end of next week. It's just a never-ending wave train of systems, and it just doesn't seem to stop. Here's another look. This is a little bit of a wider view. So there's system number one. You can see it moving out. System number two, ripping, coming in Friday morning. Then you see it clear out. Hey, guess what? We're beautiful for the weekend. Clouds will start rolling in Sunday evening. Here comes the next weather system diving in. You can see it Monday night into Tuesday morning, perhaps bringing a little bit of precipitation. Here comes the next one that comes in for Tuesday. And then look at the next system that's on the way to the northwest of that. And then look at the next system that's beyond that. And it's just flinging out these systems left and right. It's like, would you stop already? It's not. Kingston is tired in the bullseye. Yeah. So tomorrow, here's what we'll do. We're going to bust out the 8-ball. We'll give it a little bit of a rest tonight. Expecting NWS Tulsa to issue any advisories? I do believe so. Little Rock will as well, but you won't see them tomorrow morning. You'll see them probably Friday morning when you wake up. Maybe Thursday night. It's a tough, difficult forecast. There's no doubt about that. So, is that from the balloon? Yeah, maybe. I don't know. That's exactly the way the balloon traveled too, with the upper level winds. So that was that was interesting for sure. It was neat seeing that F-22 flying around. Why does it always seem we're getting winter weather when we haven't had last in a few years? So it's been a very active weather pattern, and the cold air is coming in. And someone wanted me to mention the sudden stratospheric warming event. So when something happens with the Arctic Oscillation, which is basically, let's just imagine this right here. Here's the Arctic Oscillation. In the mid latitudes and the northern poles of the world, excuse me. I don't have a globe and I don't have a ball, but imagine air is circulating and it has a speed that it circulates at. Well, guess what? That doesn't allow the cold air to come down. But what happens with these sudden stratospheric warming events is that you weaken that polar vortex. You've heard that term before. But when the polar vortex weakens, that allows that cold air to start seeping down. This camera is absolutely freaking out on me. But that's the polar vortex. And sudden stratospheric warming events tend to weaken the Arctic Oscillation. And when that happens, that allows the cold air to plow south. So we're not done with winter. We've got more coming most likely at the end of February into early March. I'm going to fly south for a few days. Oh, good idea. Can I show how the instability forms in the upper levels if I have time? I have time for that because I was actually going to show that. It's all about lapse rates. And Stephanie, I see your message. I'll get to that here in just a second. It's all about lapse rates. Lapse rates are important because it's showing you the temperature decrease with height as you go up in the atmosphere. And so if we look, we're going to go back to the HRRR, but here's the deal. I've got to load up. Let me see here. The wrap for Fayetteville, it goes out far enough. There we go, right here. So you'll notice this right here, you can kind of see the parcel process curve. When it cools off fast enough, right here, you'll notice that we have just a little bit of instability. Because if I zoom in on this, you'll see a little bit of that yellow line. Let me see if we get a better one here. It's not extremely sharp. I think the HRRR looked a little better. There you go. There you go. Now you get to see it. Let me zoom out of here a little bit more. So I don't know if you can see this, but this yellow line right here is your parcel process curve. So what's happening is you're hitting the moist adiabat and you're to the right of the profile. So you actually have some instability right here. That instability will allow for rapidly rising updrafts. And because you have enough cloud ice, you could have the collision of ice particles and water, which will build up your lightning, which is why there could be some thunder snow that happens. Now, at that point, it's not snow, but it's pretty darn close. Let's see if we get any other instability here. So a little bit there. Yeah, a little bit there. You can kind of see it right there. Just a real small parcel process curve that's just out ahead of it. And then it kind of stabilizes. It doesn't last very long. Let me do this real quick. Let me load up the HRRR. This won't take as long. I can get the long range HRRRs. All right. And then I'll load it up here by going to this. Now we can look at the instability with the HRRR, and you're going to see it a lot better here. All right. So that's Thursday's system. And then here's Friday's. All right, so let's see when it starts snowing. It's just barely there. There you go. See that, how you have lapse rates where temperatures are cooling rapidly with height? And there's your instability. That goes all the way from about 5,300 feet all the way up to about 10,000. So about 5,000 foot essentially depth of instability. So imagine I'm a hot air balloon and I'm rising. Well, when the air is warmer than myself, then I'm not going to rise anymore. But if it's colder than my temperature, then I'm warmer than the environment, so I'll continue to rise. And that's where that instability comes in, right there. A little bit of what we call slantwise convection. So, yep, that's what we're talking about. That's what we're showing right here with all this. There could be some thunder snow on Friday with this type of system. And we looked at this by looking at this right here. This is the instability. We can look at it a couple other different ways too. We'll look at called lightning density, or the lightning flash rate. And this is for the HRRR. And we'll look at it. It's there on Friday. Not a lot, but it's there. See it? Right in there. And that's right over Northwest Arkansas. So, and then it kind of really bumps up around 6, 7 o'clock. And then look at that. It actually cranks up. So there could be a couple hours of lightning potential. One of the reasons is this system has some really cold air aloft to work with. So that's why you're going to get that potential. When we look at the upper air temperatures, you look at the 500 millibar temperatures, they're pretty darn cold. Minus 20, minus 30. So you got some cold temperatures aloft. Okay, quick recap. Sorry, that took a while, but I thought that'd be kind of cool to show you. All right. Stephanie, I hope you're still on here. For those joining late, here's what we've got. We've got a little bit of a light rain that's coming through now, and that's going to bring precipitation. That's going to be mainly in the early morning hours on Thursday. Then we've got the Friday system. This is what we're talking about when we could see the potential for some thunder snow. That is happening Friday morning. It looks like it's probably going to start before sunrise and then really crank up right around sunrise and then start to drop off. So that's what we're looking at with that. Next is the timing of all this. That is the timing. Let's show you the future track radar. This is a beautiful day on Thursday. No problems. High clouds roll in. I think we'll already start to see rain by Thursday night before midnight. Then you'll notice the precipitation coming in. Remember, we're getting that dynamic cooling aloft, which is not really having that dry air. That's another thing, too, that the models have that doesn't really exist with this system compared to what we had with the snow that happened back in late January. We had a lot of dry air, so that had to dynamically cool the atmosphere. This system doesn't have to dynamically cool. The surface temperatures will, and that will happen. But as far as cooling the column, that's not going to be the case. There you see the 32, 31, and, quick burst of snow. The roads will be soaked initially, and these snowflakes will be instantly melting on the roads. But if we do get those bursts of heavy snow, that would lead to slushy conditions. It all depends on how much we get, too. Now, when we move into Friday night, the temperature is going to drop below freezing. We clear out. And if the roads are still wet, which is a possibility, Stephanie, then that could be a little bit of an issue. So, and then next week we got a big system moving in, and I'm really concerned. I mean, really concerned about the flooding potential because we've already seen the incredible heavy rain from this system. So let's show you what we've got. Here's Monday night into Tuesday morning. Now look at this. This is a very large system. This has a lot of precipitation. And remember, this is a global model. So clears out a little bit on Wednesday, but guess what? The next system's coming in for Thursday. This is another intense system. Probably could bring severe weather potential. And then look at how close the winter weather gets. It's not very far away. You can see that just to our north. And then that system starts to move out. So another winter storm coming for Kansas City as of now. So severe weather is definitely a possibility with that. In fact, if we look at the Cape with that, there's definitely instability returning. No doubt about that. This might take a little while to load. Let's see. So here's the Cape. Now, this probably won't show the Cape because it's a global model and the data hasn't loaded yet. Okay, so here's the instability for Tuesday. It doesn't show up. There's Thursday. So Thursday's system already starting to show instability coming back. So Mark, thanks for tuning in. I appreciate it. And for those that are watching the replay, I commend you for making it this far. I doubt you did, but I got to drive to Fort Worth, Texas Friday. Are we going to be okay? Yes, you're going to be okay. Roads will be no problems initially, but maybe a few slick spots, during the afternoon, unless the storm system just blows us all away and it becomes a really heavy, localized beast of a storm, which is not out of the question, but I don't know. I have my concerns about this system, and I just have a gut feeling that we already had the surprise in Oklahoma today and tonight with that snow. I think this is a much bigger system that wraps up that is going to bring maybe some more surprises. So, but you won't be surprised. You watch this whole thing, and now you know. And yes, if we get a heavy wet snow, we might want to watch the trees due to very wet ground. The very wet ground could also cause some trees to come down as well because the root balls are very loose. That's going to happen most likely with some of these damaging wind potentials. We've got a serious problem with this active weather pattern. We're going to get some bad rain next week, and the ground's already saturated, so our flash flood guidance will be very low. Okay, Michelle, thank you so much, and sorry your yard is flooded. Thanks everybody for tuning in. I eventually got to leave this place. I'm going to be doing that right now. And thankfully, I got some help tomorrow. I got West Fork schools coming in for a tour of the place, and you'll see them on the 6 o'clock news. And until then, man, you have a great rest of your what's left of it, your Wednesday. It's trash day. I can't wait for my trash to get picked up in Fayetteville tomorrow. But that's going to take a half hour to put outside. Take care, guys. Have a good one, and God bless. Hey, thanks for watching. Really appreciate you guys. That's why I do what I do, to teach you, to educate you, let you know about the weather, and give you the heads up. See you guys.